Hey guys, welcome back to WP Development's YouTube channel. Today we're going to be talking about the 10R80 and the gas application, which is a 10-speed transmission that is in the V8 powered, some of the V6 powered stuff. They are most commonly like in the F-150s and the Mustangs, high performance applications, heavy duty applications and stuff that we offer here at WP Developments. Just kind of some pieces in the background here that we'll go over of the most common stuff that we do fix in there, some of the issues that we're working towards fixing, some of the factory updates, if the 10-speed is capable of what we think it is, just some of the keynotes that we'll go over in this video. You probably came here from our other 10-speed video. It was kind of a general overview of 10 speeds in the GM diesel gas platform. We're going to start out with the gas stuff. So in the 10R80s, you guys have probably seen, say, like the F-150s and the four-wheel drive applications and these Mustangs bolting on blowers that are running 5-second, eighth-mile passes. Some are down in the eights. They're getting very popular. Some people are switching over to turbo 400s in that application, and you probably wonder why. So anytime there's a new transmission design development, technology has to kind of catch up with that new design. So when the engineers go through and they start doing, say, different shift strategies or the way they lay out the valve body differently than what we're used to, now all of a sudden, as a transmission builder, we also have to be hand in hand with our transmission tuner. So that's normally going to be like your ECM tuner right now. That person is going to do your engine and transmission tuning. It is very important that your tuner and your transmission builder are talking, and that transmission tuner is also doing the things that your transmission builder needs done in order to keep your transmission alive. Some of the technology that we face here is, I'm sure you've heard of it, is skip shifting. Skip shifting is an algorithm that Ford had programmed in, as well as they did non-skip shifting. And I'll tell you the benefits of skip shifting versus non-skip shifting. So a lot of people are going back to the non-skip shifting because they want a guaranteed gear exchange on every shift and high performance, which is great. I understand it. It makes it more reliable, more predictable, and more reputable for the number that you're going for. As of the skip shifting wise, the reason Ford would do that is because the rate of gain, how fast your transmission needs to switch to the next gear, is so quick that it physically it knows it can't make the change from, say, first to second. It needs to go from first to third or first to fourth. And when that happens, normally is in a burnout. And I know in some of my other videos I kind of explained the downfalls of doing a burnout without skip shifting. And here's what happens. So you pull up to the burnout box and say you have a trans brake or you brake boosted or whatever, and you get those tires spinning from 0 miles an hour up until, usually they peak right there at like 80, 90 mile an hour within a split second. The problem with non-skip shifting is that transmission is told it can't shift from first gear to seventh gear in an instant. It needs to hit 1, 2, 3, 4, 5, 6, 7, and it physically cannot do it in that fast manner. So what we see a lot of times is the bind up of multiple clutches on at one time from having the skip shifting turned off. Now in racing, we don't want it to happen, on the racetrack, so it's more predictable and we can count on that gear holding the power and what gears it's going to use. But say in a burnout application, we definitely don't want it to try to shift up from first, second, third, fourth, fifth, sixth, and seventh in an instant, because it will literally block every clutch on at once and it'll start burning them up. Another thing that we have seen in the burnouts is the Sprag assembly on the B clutch. It's in hold. When we see it go from first to second, it is making a lot of strain on these roller Sprags. The roller sprags themselves in the burnout application is always hard. These roller sprags, obviously, they have more leniency on, on the burnout stuff, but we are seeing high mileage units on these starting to compress these springs, which is, if you've watched my Sprag video, you understand it is total failure. So we have been seeing these B-clutch roller sprags starting to fail in not only high performance applications, but high mileage applications. They're starting to get a little more slack, the springs are starting to become loose, and all the rollers aren't starting at one time and causing a big failure. So that's on our list for high performance wise. We're working on this Sprag assembly. Our units specifically come with a new pump support, which also comes with the new Sprag assembly with the race installed in it. That brings us to some of the other stuff on the not just racing, but in everyday driving. I'm sure some of you have heard of the CDF drum. That drum has a bushing in it that is known to start to spin in its location. So it probably wouldn't make sense until I show you the inside of this drum that we have actually removed the assembly from. So the heat that Ford recommends that you be in, as well as somewhat lack of lubrication. I wouldn't say that it's it's not the flow of lubrication. I would say it's more in the makeup of the trans fluid, which we are working on. Having a good alternative for that with plenty of lubrication. But one of the main things that we don't like is the fact that they do run very hot. So this same exact drum in a Chevy application, we don't see those bushings spin nearly as much. And one thing, there's a couple things that is different between the GM and the Ford. And one is the fact that the GM runs way cooler. So instead of having coolant temperature be your trans temperature, so about 200 to 210 degrees, the GM side, they'll be 130, 140 degrees in your daily driver rather than the 200 degrees. On top of that, their transmission fluid is also different. So it probably has more lubricity factors in there, and the fact that it isn't as hot, so it's not swelling that bushing as bad and creating, it's not creating this drum here to expand and loosen up its tension on the bushing. So I'll try to get in here a little closer. What you have in here is, this is the drum, the CDF drum that would host a bushing in there. And the bushing's about, 4 to 5 inches long, probably 4. And it has different holes in here that actually feed each clutch. So there's 3 different clutches on this drum and 3 different pistons. And so the design of this drum is very crucial that bushing inside there cannot spin, because there's individual holes that line up and feed each hole to feed your piston on or off. And it also does lubrication. So if that bushing spins, it basically lacks pressure to your clutch for apply. It also lacks fluid to your rear gear train and doesn't allow it to be lubricated, and then we start seeing gear failure. So kind of in this drum here, you can see this one, you can't see the lines in with the feed holes. This actually has the bushing installed. This is an updated drum from Ford that we use in all of our units. They actually put a little shelf in here and create that and a little bit tighter press fit to basically make that not be able to slip out of its groove. And when we have this type of bushing with that shelf in there, we have not seen failures yet. But as well as when they come in and we upgrade them, we also do a thermal bypass. So the thermal bypass in the transmission is based off of, it's a thermostat down in the valve body that as it heats up, it basically opens a valve to go to the cooler. If it's cold, it just bypasses the fluid from the cooler and just does a circulation loop. So you can imagine how fast that gets hot. So when we lower the temperatures in the Ford transmissions, we can kind of keep that bushing from moving even without the updated drum. which is super important. You know, lubricity is the other huge factor that we talked about. I feel like Ford could probably, you know, redesign their fluid a little bit and add some more lubricity. It's a very thin viscosity, and they want it watery thin. I understand their theory behind why they want that temperature to be as consistent as possible, because in technology, we have 10 shifts to make at a certain temperature, and it has to be the same every time to get consistent shifts. So the shift quality and the shift feel is going to be consistent if they can make that common denominator, you know, one temperature. And that's kind of what they're after. As well as if the fluid's warmer, it does have a thinner viscosity, which means it's more watery, and it is more capable of moving the shift valves and stuff at a certain level of speed. So if we have cold fluid, it does make more pressure, and it's possible that it does come on and off or shift harder at times. So, you know, that's some of the things that we have to look at as well. You know, when we drop temperature in these things to say 140, 150 degrees, we also have to be careful and make sure that the shift timing and everything is not going to be interrupted and have you a shift flare or a shift tie-up. As I was saying in the CDF drum bushing spinning as well, the lubrication on any product basically that is past the CDF drum, so going in the back of the transmission, is going to start to lack lubricity. So lubricity on these, as you can tell, this hub goes into that CDF drum, and it had a bushing spin, and it cut off all of the rear flow to lubricate the rear housing of the transmission, as well as our rear planet that sits in there. This is not supposed to be brown, and this bushing inside here is not supposed to be ate up like it is. So some of this stuff is primarily just that one failure of a bushing spinning in the CDF drum that's creating these big problems. So there is another update on this actual Planetary and gear here, that whatever it takes transmission actually designed, they noticed that they were seeing excessive wear on the gear because they didn't ever put any type of bushing in here for metal on metal wear, and this thing is sitting in there just cooking. So there is a design where they machine the gear down and they machine this lip off a little bit and have a tabbed thrust washer that sits in there and kind of keep this heat and wear out of there. We're seeing a ton of material going through these transmissions, and I understand why. You know, some of these Planetaries, I think they released before testing a little too soon on not having, simply not having some type of Torrington bearing or thrust washer in here to keep it from getting hot and wearing on itself. You know, once that material starts coming off, where does it go? It goes right down into the pan. It gets sucked back up because the media and the filter can't quite catch it all the way, and it ends up in your shift control valves. Then you have, say, like a solenoid E stuck on or solenoid A stuck on, and you think it's the death of the transmission. It might pull in reverse and neutral. It might pull in reverse and park. And that's just simply like material from, say, like your transmission cooler, or, you know, things deteriorating, getting in that valve body and creating those valves not to move freely. So it's a very hard balancing act inside that valve body, which is what we're working on now. We have a lot of modifications that we do to try to get that balancing act further apart. And what I mean by balancing act is you have a solenoid in there that when you put 12 volts to it, it sends out this little needle and it pushes a valve. So it's actually a mechanical, they call it a direct acting solenoid, and when you put 12 volts to it, it pushes a valve and it shifts it in the bore. Now, if that bore has just the slightest bit, and you probably wouldn't even notice it by moving it with a hand, but if it has just a little piece of debris, say from this gear wearing on the Planetary assembly that happened to get into a shift valve, it would cause it to basically not have enough force on that electronic solenoid to shove that shift control valve, and you're not getting the next gear exchange. Then you start getting a limp mode. It's going to throw you a code that says, hey, this solenoid is, or this valve is stuck off or stuck on, whatever way it ended up. And that solenoid itself has 5 pounds of force. So if we have just a little bit extra on that valve, that is basically holding it up and keeping it from shifting in the bore and not getting the next gear, it might look like to you that you need an entire new transmission. And that's not the case. We need to keep the fluid clean. We're working on some filtration stuff here in-house. We're working on some better fluid that has some better properties in it that keeps basically some of that debris from being able to stick to the valves and adhere to them. We're modifying the shift control valves here in-house. We've recently started that we found that is making a huge change on, if that shift control valve gets stuck or not, as well as this portion right here that is considered called, I guess the Lane's terms of called the trash can. So this is probably what you would see like in a Ford. Ford calls it a cylinder. In the transmission aftermarket world, we call it the trash can. This trash can is what holds absolutely everything basically of your transmission inside of it. All your clutches stack up. Your notorious F clutch is what splines into here. Some of the things that we were seeing and these in particular were the splines inside here for your F clutch were actually engaging so hard that they were making a little shelf on each one of these ridges on the splines internally and causing basically the F clutch to stick on or have a hard time coming on time. And what they have done at Ford to fix that recently is they did a hard coat anodize to these drums. So the new part number for these drums that you might see is the hard coat anodized, and you would tell by it being black in color, not raw aluminum. So that's another thing that we do in every one of our builds, whether it be for performance or heavy duty towing or anything like that. As well as, the Raybestos GPZ frictions have been great in these 10 speeds so far. They have reacted to multiple drag racing hits. They have reacted to multiple towing applications, daily drivers with just a little bit more firm shift feel once you put that in. So not to be worried, it's not anything wrong with it, but that friction really likes to grab once it hits its spot of pressure where it needs to be to grab, for that element to grab and pull down the power. That shift feel is going to be a little more firm, whether it is in your daily driver or your towing applications or performance. Just because of the way that friction is it does not like to slip. That friction is ready to basically grab and go, is what I would say. So in return, that would make a little more firmer shift feel for you on that. Some of the other things that we're seeing with the 10-speed gas applications that we've learned are the cases themselves. I don't know if you have looked at them, but make sure when you do order a transmission that to whoever you're ordering one from, that you tell them it is a 2-wheel drive or a 4-wheel drive, whether it's in a 22 up pickup. It's best to give them the VIN number, because there's so many different variations of CDF drums, valve bodies, case configurations. In the past, we have always had the transmission case casting of the case be the exact same for 2-wheel drive, 4-wheel drive applications, as to where now, for whatever reason, they have actually casted them differently. So if it's a 4-wheel drive application, it doesn't have the 3 bosses on the back for your 2-wheel drive transmission mount to. It would have more of the transfer case bolt pattern on the back for a four-wheel drive application, as well as the output shaft itself is drilled and tapped in the center for a yoke on a two-wheel drive application versus a four-wheel drive. So there's a lot of different little things in these transmissions that we absolutely have to know. As crazy as it sounds, like the V6 bell housings are different than the V8s. So they have a very wide spectrum of different casting configurations that we definitely have to make sure as a builder that we match what you have. It's not as simple as saying we buy 20 cores and this 20 cores fits 18 through 24 on Mustang and F-150, or two-wheel drive and four-wheel drive, or V6 and V8. There's a ton of different configurations. So make sure whoever is building your stuff, to keep the time frame down, you are up front with them and either give them a VIN number, or you tell them, hey, mine's a two-wheel drive V6 or it's a two-wheel drive V8. Kind of give them all the details that you can about what you're wanting and what you're putting it in. So that was kind of crazy to see all the different configurations as we were learning these things. That's never been in the case before. As of maintenance wise on the 10R 80s, 10 speeds in general, I tell people a lot that the Ford and Chevy have a service interval that is absolutely wildly long to me. It's never going to hurt to change your filter before the manufacturer says to. If you are hard on your stuff and you're using it for a workhorse or you're out drag racing, there is no shame in being able to change that transmission filter every year at least. I would say if it's a drag racing application, you definitely want to keep your eye on your data logs and make sure that your commanded versus actual shift times are staying true, making sure that your desired and actual pressures are staying spot on to what you need. If they are not, it does not ever hurt to drop the pan and get a new filter in there, replace the fluid that drops out, get a fresh filter in there, so under high stress, high RPM applications, it can get all the volume that it needs through the filter. And keeping it clean is only going to help you in the end. It's going to keep that valve body bore from wearing out. It's going to keep that valve body shift valve from sticking. It's going to help you tremendously in the long run. So maintenance wise, if you're daily driving this thing and you're putting a ton of miles on it, I would say if you changed it every 30,000 miles, it would be a good idea. Like I said, it's not ever going to hurt to have it run cooler. It's not going to hurt to overchange the filter in it. As long as you stay on track and it's not too far gone before you put fresh fluid in the pan, you're not going to see a problem. And we never want to do a full flush on it. We just want to be able to change out what comes out of the pan when you do your filter swap, put new fluid back in it. You can clean the bottom of your pan or whatever, but we don't ever want to do a total flush of the system. Usually what we see when total flushes happen is actually, they do not last long. It takes all of the fiber out of there that some of that friction is grabbing a hold of, and it ends up smoking your clutches really quick. Another thing, I don't have it up here on the bench, is some of the pump assembly. The pump assembly is very weird. If you're used to transmissions, the pump assembly actually bolts to the bottom of the transmission. It is ran off of an idler gear, which is also ran off of where your converter goes into your pump housing, and that converter runs a gear. Normally in a transmission, the converter will be directly ran into an inner pump gear, and as that spins, it creates pressure. So on the 10-speed Fords and Chevys, they have basically a floating gear in there that your converter splines onto, and then they drop down and have an idler gear with a bearing in there, and then they drop down again and bolt a pump to the bottom, and so it has a middle gear that's driven from the engine through the torque converter on the snout. And some of the things that we were seeing in the high performance application was the fact that the flex plates were not strong enough. So what I mean by that is under high strain, that flex plate was moving so much that we were getting gear walk, which was also causing the internal bushing on the torque converter to eat itself and start to basically dislodge itself from being pressed in the snout and causing a huge mess. On top of that, it was creating such a havoc on flexing that the splines of the gears, the mesh of them was not far enough down and would start pulling the gear apart, and they'd get nose to nose and they would start stripping gears off of the idler pulley. Once that gear falls down, it starts stripping all the gears. So a big thing that we're working on, and we do have a sample I can grab real quick, that is a SFI billet flex plate for our high horsepower stuff. It would never hurt to put a heavy duty flex plate in any vehicle. I always recommend it, especially like in our diesel stuff. We always do a billet flex plate that's SFI rated, just to get that stability in the torque converter. And under power, you know, we're not getting a whole lot of flex. Now we can't have it too stiff where it doesn't flex, but we have it stiff enough where it doesn't have as much run out on those pump gears, and keeping that torque converter centered in its spot where it should be will keep us from being able to shear those gears on the pumps themselves. That was one that we went down a rabbit hole on, couldn't figure out why it kept eating the inside bushing on the torque converter itself. They were walking out, they were creating a mess. We're seeing tons of material in the pan, and then we started seeing the gear failures under high horsepower, you know, from that flex of the flex plate, allowing the run out of the converter to be way too much. So we worked on that a lot in the last 6 months. We do have a sample piece we're going to put in our personal trucks and try to put as much horsepower as we possibly can at them. So the pump assembly, you know, if you do get a bunch of debris, it's just like any other pump. It'll start getting excessive wear in the pump gears, and you'll start getting cavitation from the air being able to suck in through the grooves. So you just got to be sure, if you do have dirty fluid and you're having some shifting problems, it's probably not a bad thing to go ahead and replace that pump. We don't need excessive pressure. There's no need for it. You have plenty of pressure in your transmission that's capable of building plenty of pressure for us. What we're seeing with some of the pressure increases that people are doing is we're actually seeing the reaction plates flex so much that you're actually losing surface area on your clutch apply. So imagine like if you have 375 pounds of line pressure, all of a sudden the pressure plate that you're pushing against starts to do this and concave. Now we're not getting a flat apply area. So in the transmission building world, I think that's highly overlooked. We have proved that in multiple different applications throughout transmissions in general. Sometimes it's not about getting more frictions in, it's about what you're pushing against. And how hard you're pushing against it. It's not always the answer to jack up line pressure to hold it, because you could be concaving what you're pushing against, and now you're only wearing on the outside 50% of that friction, which is obviously no good. Everything you added, you just taken more than that away. So you have to be careful on doing some of that stuff. High pressure is not always the key. Not saying that the rate of gain isn't a key. You always want to make sure that that thing ramps in really quick. You know, to hold the power, you don't want a long drawn out pressure ramp. It will slip the clutch, especially with GPZs. Don't like to be slipped. It will eat them up in a hurry. You want that basically to be snappy, quick, and clean. So shift quality on point. So we talked about some of the flex plate area, about how we were seeing it flex under high horsepower. This is kind of our answer to that, which will be an SFI. This is actually a sample for our vehicle. We're building a couple F-150s with twin turbos on them here in-house for ourselves. Our goal with my personal one is to be, you know, 2400, 2400 horsepower twin turbo with some nitrous on top. And we really want to see how far we can push this 10-speed. Probably we'll get into some standalone operation stuff. I have a lot of goals with the truck. I'll be dedicated. It'll have a ton of data logging internally on the transmission to try to learn and do as best as we can with it. This is one thing that we really need on the high horsepower applications. I feel like for the gas side of things is this will keep us basically from flexing and making that converter walk and creating failure in the pump gears themselves. That was a huge benefit. Hopefully this will be tested very soon. Make sure fitment's good. We'll do some stress tests on it, make sure that it's strong enough, or if it's too strong, we'll make some adjustments, but they should be hitting the market here in 2025, which will be awesome. It'll be an affordable option for everybody to, have a billet SFI flex plate in their F-150 and their Mustangs. So I think that kind of sums up what we have going on. If you want any more details about the 10R80, feel free to reach out, comment below. There's a lot of things in there. I'd be talking for hours upon hours. I can't fit everything in there, but if there's a specific area that you have questions on or concerns on that I can help you with, please reach out. Thank you for watching the WP Developments YouTube channel. Subscribe below. The next one will be on 10R 140s for the diesels, and can't wait to talk about that. These 10 speeds really have all of our eyes on it. We've been working day in and out on getting some of these answers. We're consistently developing new products for them and testing here in-house. Our F-150s will be built to the gills to try to break them and see where the failure points are. That's kind of our cup of tea, is to try to overstrain what we got going on and see where we can break it. So stay tuned. We can kind of show you around the F-150 here. It is on our Facebook channel. You can always go over there to Facebook and watch the F-150 build progress. We post it occasionally. We should be having that thing up and going in the next couple of months, so it should be pretty sweet to see. Thanks for watching WP Developments. See you on the next one.